In-class activity 11D, fractional exponents. Using the product rule for exponents, x to the 1/2 times x to the 1/2 equals x to the first. So what quantity does x to the 1/2 represent? So x to the 1/2 represents the square root of x. And what about x to the 1/3? So x to the 1/3 would be the cube root of x. Okay. Objectives for the activity. You will understand it may be easier to work with complicated expressions when these expressions are written using fractional exponents instead of radicals. You will be able to rewrite an expression that contains radicals by using fractional exponents, apply the rules of exponents to simplify an expression containing fractional exponents, and evaluate and interpret expressions written with fractional exponents. Let x be a positive number and let m and n be integers. We define x to the m over n to be the nth root of x raised to the m power, which is equal to the nth root of x to the m power. Part 2. Rewrite each of the following using fractional exponents. So the cube root of x, we said just above here that is x to the 1/3. And then part B, the cube root of 2 plus x to the 5th is going to be 2 plus x to the 5th, and that's all raised to the 1/3 power. And then here we have the square root of x minus 5 to the 3rd power. So we're going to have x minus 5 raised to the 3/2 power. And finally, let's see, the square root of x cubed plus the cube root of x squared is going to be x to the 3/2 plus x to the 2/3. And there's one more here. I'm just going to go to the next page all the way here and work on part E. This we can do in 2 steps. We can write it as 1 over x plus 3 to the 1/3 power, which we can write it as x plus 3 in parentheses to the negative 1/3 power. Number 3, the rules of exponents that you reviewed in preview assignment 11D also hold for fractional exponents. Simplify each of the following expressions using those rules. Whenever possible, reduce the exponent to lowest terms as you simplify and write your answer using positive exponents. Assume that a, b, x, and y are all positive. So part A, I'll just work to the right here. We can write this as 27 to the 2/3 times x to the 6th to the 2/3. 27, we can rewrite that as 3 cubed, and that's still being raised to the 2/3 power. And then x to the 2 times 6 is 12, so we'll write that as 12/3 power. And 3 times 3, that's going to be 3 squared, times x to the 4th, which is 3 squared is just 9, x to the 4th. Part B, the cube root of 32 times y to the negative 3. So equals, we'll separate this into the cube root of 32 times y to the negative 3/3 is equal to, if we simplify the cube root of 32, we get what? 2 times the cube root of 4 times y to the, this will just be a negative 1, and we'll write this as a fraction, 2 times the cube root of 4 over y. Part C, you're going to get x for the numerator, x to the 3/2 power over x to the 1/2, and then we know that we can take x to the 3/2 minus 1/2 ends up being 2/2, which is simply just x to the first, or we'll write x. Part 4, an ice cube maker is promoting a new larger ice cube. The company claims that these cubes have twice the volume as regular ice cubes and that they will cool down your drink more quickly. Let the first ice cube be represented by C1. Suppose that the length of each side of C1 is given by X, and the volume of the cube is given by V. Part A, write the volume of C1 as a function of X. So volume of C1 as a function of X, we could write it as X cubed. Part B, write the side length X as a function of volume. Let's see, since V of X equals X cubed, then X of V is going to be V to the 1/3 power. Let's go to the next screen. Part C, the surface area of an ice cube also affects how fast it will cool down a drink. Let the surface area of C1 be represented by S1. Write S1 as a function of X. So S1 as a function of X equals 6x squared. Part D, find S1 circle X of V. So S1 circle X of V, just by definition of composition, is S1 of X of V, which is S1 of, we found this earlier, V to the 1/3, which is equal to 6 times V to the 1/3, and we have to square that, which if we simplify it, we get 6V to the 2/3. For part E, let's see. What does the formula from part D tell us? From part D, that tells us the surface area of C1 in terms of its volume. Okay, and part F, suppose a second cube, C2, has twice the volume of C1. Compare the surface area S2 of C2 with the surface area S1 of C1. Is S2 more than twice the surface area S1 of C1? So let's see, the volume, I'm just going to do this in a step here. The volume of C2 is 2V. From part D, let's see, we have S sub 2 is equal to 6 2V to the 2/3, which is equal to 2 to the, that's supposed to be a 3, 2 to the 2/3 times S1. All right, so that tells us the surface area of C2 is 2 to the 2/3 times the surface area of C1. And that's approximately 1.59 times the surface area of C1. And that concludes this video.